Now we are going to talk about another very, I would not say disruptive, but very contributing technology for the drip irrigation. So Janice, the floor is yours. You're going to talk about.
Yes, good evening. Well, it's morning there, I guess, or afternoon. I'm in Pakistan right now, so it's about 11 p.m. So hello from this side of the world. Roger, thank you for the introduction. I would just like to say it's been interesting to hear all of you speak, because I truly think the global problems need many solutions. So all of these innovations are an integral part of accomplishing the problems ahead of us. And as Marcus mentioned, it would be so nice to see everything organic and us doing a better job of taking care of the environment. I think some of these products can do that. I'll tell you a little bit about our system. We are an irrigation technology, so we're a water and nutrient delivery system. It is disruptive in the field of irrigation because it is the first system that is plant responsive. So the flow is regulated by the plant needs. I'm trying to move to the next slide, so I think I'm going to say next slide. Okay. I'll tell you a little bit about how it works. Traditionally, people have used irrigation methods such as center pivot, spray. Drip irrigation came onto the market as far back as the 60s. There's been a lot of improvements in drip irrigation, but most of that has been related to more precision irrigation, improvements on the emitters, and also in the controllers and satellite controls, weather stations. But as far as actually delivering what the plant requirements, that's where our technology has changed. I think, there we go. Our system is based on chemistry, so it's not a mechanical system. It uses the chemistry from the root exudates to interact with our tubing material. So the material itself is a microporous system, and it is hydrophobic in nature. So what happens is it just holds the water, acting like an underground river in the soil. When the plants need moisture, that's when the system releases it. This talks a little bit about what's happening underneath the ground. The plants are not unlike humans. We have a complex chemistry that regulates our functions. The plant's roots do that same type of function underneath in the surface of the soil. And what is going on is while the plants are growing, they have certain needs for light and water and nutrition. The roots send out chemical exudates into the environment, into the soil or the media that surrounds them to try to obtain the water, the nutrients that need it. Plants, when they're thirsty, can't, if there's moisture in the soil, they can't suck up the dirt. They have to extract the moisture from the soil. What they use is these chemical exudates to do that. Our system is in the ground waiting as that underground reservoir. When the exudates are excreted into the soil, our system starts releasing the water through the micropores. It continues to release the water at a slow rate until the plants have been satiated. When they have enough water, they stop emitting that chemical exudate seeking the water, and then our tube goes back to a static state and no longer releases water. What are the features and benefits over this system compared to traditional irrigation? We only release water when the plants actually demand it or need it. So you're going to get, we save a lot of water. Depends on the system that they're using, but we've seen water savings anywhere from 30% to 90%. So if they're using spray center pivots, we can get a 90% water savings. Even over traditional subsurface drip irrigations that are efficient and using smart controllers, we've still seen a 30% and higher water savings. I'm sorry, I'm having lower pressure. We work on very low pressure. So the system does not require electricity. It works very well in remote areas. We have a distribution in Africa. They are able to irrigate fields, and they are irrigating in refugee camps and displaced person camps simply using a rain barrel or a raised water tank. So we're able to irrigate without pumping water distances, without electricity, and without electronics. So there's a definite reduction in energy consumption. Fuel costs, some areas have been using diesel fuel to run pumps. Here in Pakistan, they're moving water from ponds and wells and doing flood irrigation. So we are replacing the flood irrigation. What we've also seen is that the plants were delivering water when they wanted, when they needed, at the time when it's critical in their growth and development, and depending upon what's going on in the environment with heat or rain. And what as a result is we are seeing faster plant development. They're more resistant to diseases and pests, and we get much higher yields. We can talk more about the yields a little bit later in the presentation. More importantly is, where is GrowStream applicable? It has applications. Any place you've got a plant with roots, it's going to work. It responds to the roots. In agriculture, we're using it, and our focus is again towards regenerative agriculture. We are encouraging farmers to, our system, once it's in the ground, will stay in the ground. So it isn't pulled out or removed. It's not disposed of. It's left in the ground. If they do no-till or low-till practices, they just use the system year after year. So the material itself has a life expectancy of longer than 25 years. So it will get them many years of growing. We're working in orchards. We're introducing the intercropping and alley cropping as well, so they are able to introduce biodiversity in the fields, as well as get multiple crop productions out of the same area space. We work very well with vineyards, orchards, semi-permanent type crops like alfalfa. We are being used in seasonal crops on farmers that are doing regenerative practices and not tilling. This is a little bit, these are images from Africa where our system is being installed, and you can see the tank systems there. There are higher reservoirs in the background, water tanks that are holding it. They disperse it to lower barrels throughout the fields, and then the water is released. We're operating at a pressure of 1.5 to 2.5 psi, so very low pressures. Typically, drip irrigation is at least 10 psi to 15 psi. Some lower models may work at 6 to 8. We're the only system operating between 1 and 2 psi. Where it's also applicable is in urban environments. They're using it for vertical farming, also in food factories, manufacturing with trays. We don't have the excess water and moisture running off, so that the moisture around the plant roots is fairly dry, the media. It's only delivering small amounts of water at a rate that the roots can absorb it. So the plants are continually sipping water, like pulling it through a straw, rather than us drenching the soil media, and then they have to continue to extract it when they need it. They don't have to work so hard. They get the water when they want it. We deliver nutrients in the same method. You'll see here there's vertical walls, greenhouse growing, rooftop gardens. The output and the effect of the delivery system has been phenomenal. In addition to just saving the water, we're seeing yields. And if you notice on the bottom of the screen, you're looking at Pakistan. not only water savings, but a 288% higher yield in the bok choy. The broccoli was over 300%. They actually harvested the broccoli on our side twice. Even the second harvest was higher than the first and only harvest they got from the drip irrigation side. So it's the plant health as well as the increased yields that are attracting many areas to the system. We are working very closely with other companies like those that have presented to deliver amendments and organic amendments and microbes and nematodes into the system, because since we're delivering in a very small area around a very small wetting pattern that we have around the rhizosphere, we're not flushing out those amendments that are added to the soil. With traditional irrigation, if you put an amendment on the soil and then you have an irrigation event where you put down 60 gallons of water in 30 minutes, it flushes all of those beneficial amendments, and the healthy microbial activity that's going on around the root zones is being power blasted away. It's like taking a fire hose and shooting them all out into the lower layers. Our delivery system is so low flow that the amendments stay put in the rhizosphere. We're working with a company to deliver oxygen nanobubble technology also to the root zone. So there's a lot of things that we can deliver through the tube. So it's not only water, but fertigation as well. The technology was only launched commercially at the end of 2018 in the United States at the Irrigation Association show. It was at that time that we were introduced and invited to present at the Global Forum for Innovation in Agriculture in Abu Dhabi. That was March of 2019. We won the award for the best innovation of a startup company at that time. And since then, we have been launched in about 14 countries. So we have a manufacturing and distribution facility in Abu Dhabi now, and we are in Pakistan, in Europe, in the UK, Portugal, Spain, Turkey. We're in Africa, South Africa, Kenya, Nigeria, and we're in Australia, and working with a client in Brazil. And of course, we're in the US. So any questions about, I didn't even go into the benefits. I'm sorry. Do I still have time, or do I need to wrap things up?
I think you have to wrap it up. I'm sorry, we are totally out of time.
Out of
you
time.
Can summarize it very quickly.
All right. Well, you can see the benefits of the system. I believe we're a planet in crisis. So the issue is that we need to save water. We need to protect it. We need to save it. We need to take better care of the soil. We're losing soil every year from erosion and then from chemical destruction, degradation. So we need to increase food production. Population's growing, and we need to accomplish that now, not 10 years from now. And then
thank you so much.
That's all I have. Thank you.
No, thank you so much. Because we are out of time, I won't ask my question, but I can talk to you bilaterally, separately. So I will thank you so much.